The next experiment is drain characteristics and transfer characteristics of field effect transistor, that is FET. This is the circuit diagram of the experiment. Connect the circuit as per the circuit connections on the breadboard. How to identify the terminals of FET? Now you can see this is FET, field effect transistor. You can see 4 terminals, out of which one is folded. This terminal is folded. The other 3 terminals you have to start. There is one notch here, you can see here, that must be touching your thumb finger on the left hand. Then you have to come in the clockwise direction. The first terminal is source, drain, gate, S, D, G. So for identifying the terminals, there is a notch, you can see the projection here, that must be touching your left hand thumb, and starting from in the clockwise direction, you come in the clockwise direction. The first terminal is source, second one is drain, third one is gate. So these are the 3 terminals of the FET. The fourth one is sink, that is not required for the experimental purpose, so that is being folded and kept. While we are giving the component also, we will be folding and giving it to you. So you can use only the 3 terminals, source, drain and gate. In transistor you have 3, BJT you would have done the experiment. You have 3 terminals, emitter, base and collector. Here you have source, drain and gate. Source, drain and gate. So after connecting the circuit as per the circuit diagram on the breadboard, let us go to the setup. So this is the experimental setup. So this is the input side RPSU, this is output side RPSU, and this is the connection on the breadboard as per the circuit diagram. You can see this is the connection as per the circuit diagram on the breadboard. This is the input side voltmeter. We name this voltmeter as VGS. Then we have one voltmeter and ammeter connected to the output side, that is drain side. So this is ID and this is VDS. This is VDS. Now we will be doing the drain characteristics and transfer characteristics of FET, field effect transistor. FET stands for field effect transistor. Now let us see first how to do the drain characteristics. So this is VGS, this is ID, and this is VDS. So drain characteristics is this side, output side. So for doing the drain characteristics, we must first fix VGS at some constant value, and then using this RPSU, you set some VGS at some constant value, and then vary the power supply connected to the drain side, this power supply, and note down ID and VDS in the corresponding ammeter and the voltmeter. Then repeat the same procedure for another two different sets of VGS. That is, by varying this RPSU, set some VGS constant at constant value, then vary this power supply RPSU, and then note down the current and voltage in the ammeter and the voltmeter. So this is ID and this is VDS. So you have to take 3 sets of readings. Then for transfer characteristics mean input, it will relate the input and the output. So for measuring the transfer characteristics, you have to set some constant VDS, that is, you have to vary this RPSU and set some constant VDS, and then by varying the input side RPSU, note down the variation in this voltmeter, that is VGS, and then ID. So the transfer characteristics will tell you the relationship between the input side voltmeter, that is input side voltage, and the output current. So it is a volt versus current graph, voltage versus current graph. So once again I repeat, for doing the transfer characteristics, you must set VDS at some constant value. So this VDS value can be kept at some constant value by varying this RPSU. So vary the RPSU which is connected to the drain side, and you set some constant value VDS here, and then vary this input side, that is source side RPSU, and then note down the voltmeter readings in the VGS meter, and then the current ID. So VGS versus ID at some constant VDS. So repeat again for two more set of VDS constant value. Note down by varying this RPSU, note down VGS and ID. So this is how you have to do FET experiment, that is drain and transfer characteristics of FET experiment.